All right, first question. I'll give you a couple of seconds. So this is number 1. It says find first derivative given f of x is equal to 5e to the x minus 4x plus 2. So in this case, your first derivative should simply be 5e to the x minus 4. We complete there? We're able to do that. So that's a 1. That's a winner. It's 1 for you in your hat. Question 2. Yeah, I guess I'll do question 2. All right, so it's the same thing. Same question stem. They're giving you f of x is equal to 5e to the x minus 2x to the 4th power. Find that first derivative. Solution, 5e to the x minus 8 x to the 3rd. Okay, question number 3 is just a different style of the same question. Again, remember this is a review, so I'm going to give you lots of different examples of the same thing. So you're going to get one of them on the test. So find that first derivative given f of x is equal to 8e to the x plus 4 natural log x to the 3rd. So in this one, you would have ended up with f prime x is equal to 8e to the x, and this reduces to 12 over x. Any issues? No?
From converting 4 and L, as we multiply 12.
A derivative of natural log x is what?
1 over x.
3 times 4. No, there's no square. All right, number 4. Number 4, same example. I'm going to find dy over dx given y is equal to 9 log base 3, pay attention to that base, x. I have to go back to your notes if you have to go back. This is in that chapter section that we went over where we had log type derivatives. And it had to do something with the base. Something about that base. So if I'm solving for this derivative, look at the pattern. That first derivative is going to equal 9 over x natural log of the base, which just happens to be 3. So go back to your derivative notes.
would it be wrong if I put the x at the end? Or would it be the same thing?
I believe it was
Natural
x
log K to-
natural log base over whatever value. Yeah. Okay, question number 5. Or actually question number 6, because question number 5 is all over the internet. I'm going to ask you to find the first derivative. This is product rule. So if you want to write down that this example is product rule, and then we're going to find the first derivative. Oh my god. Okay, here we go. So I'm going to give you 2x minus 4. Remember I showed you there's 2 ways you could do this. So you can literally just multiply or distribute it and then just differentiate. But if you want to use the product formula that I showed you, we could do that too. Your choice. What do you prefer? You have a preference? I think you should learn the product rule. So this is like our f of x, and this is like our g of x, right?
Yeah.
So I would do f of x on top, which is going to give me 2x minus 4. Down here, I'm going to take the derivative of that small equation, which is simply 2. Over here, I'm going to take g of x, which or the original equation is 2x cubed minus x squared plus 1. And here, I'm going to take the derivative of that function, which is 6x squared minus 2x. You're then going to remember that we're going to multiply first this way, so that comes first. I am recording. All right, so that gives me initially 2 times 2x cubed minus x squared plus 1 minus, and then I'm going to multiply this way. This is my number 2, this is my number 1. Right? The reason why I say that is order matters, because it's subtraction. So that's why I'm making a big fuss about it. So this times this, I think I'm just going to write it out. So I'm going to do bracket 2x minus 4 times 6x squared minus 2x.
Professor,
Marvin.
you go up for a second. Okay. So my question, you're doing the derivative of the second, like of the first times the second plus
Yeah.
the derivative of the second times the
So
first,
it's this over the derivative, right?
right?
And then it's this over its derivative.
And where is that minus coming from?
The formula.
Huh?
The formula.
Oh, the formula. Isn't the minus only when it's on the
The
Right.
minus is on the top, so you're doing the product. So if you remember, it's f prime g of x minus, and I always like to separate it, g prime f of x,
over?
and then all of this over the denominator, which is,
Yeah, but that's not only.
no, there's no denominator here. This should be addition, actually.
Yeah, that's what I was.
Yeah, I just had a moment. Yeah. Sorry, I was thinking quotient rule. But regardless, this works. Okay, so this results in 4x cubed minus 2x squared plus 2 And then yes, it's product rule, so it's plus. And then we end up with, multiply this times this, so it's a FOIL. So you're going to get 12x to the third minus 4x squared minus 24x squared plus 8x. So if we combine like terms, I'm going to combine the x cubed, the 4x cubed, the 12x cubed. That's going to give me 16x cubed. I'm going to take the negative 2x squared, the negative 4x squared, the negative 24x squared, and that's going to give me negative 30x squared. You're left with plus 8x plus 2, and that's your answer. The next one is quotient rule. Good Lord. We had a conversation about that before you walked in. So the question mark is BC going to be open? You know how they always stay open until, you know, the first tornado hits us. Being sarcastic. Okay, so if we happen to be open, test. If we happen to be closed, I'm going to put the test online. All right, and then this review is being recorded. Okay, so now that we got product rule and quotient rule down, this order does matter. If you notice, the order doesn't matter here because I did do the order of the quotient rule, and that's why I want you to learn this way regardless, because the products are added. Who cares the order in which they are? It's associative property or commutative property, right? 3 plus 2, 2 plus 3, same difference. But in quotient rule it does matter, because quotient rule, so in this case we're going to find there's nothing on this test right now in this review that will not be fair game on the test. So keep in mind, like I said, no surprises. All right, so find the first derivative of x over 6x minus 8. See if you can do that one. Are you getting this? And your 6x's cancel, leaving you negative 8 over 6x minus 8 squared. Comfortable? Awesome. So remember, again, this is your review. I'm giving you many more examples than are going to be on your test, so bear with. I know it seems repetitious, but repetition is how we learn. What did I say? 47?
We finalized on 18.
47? 48? That was 48. 18. Okay, so find dy over dx given y equals 3x minus 9 over 5x squared plus 8. Give it your best, see if you can do it on your own. If you answered the question, take a look at what's on the board. Negative 30x squared plus 15x. Because remember this negative affects this value here. So that's negative 30x squared. And 15x squared will result in negative 15x squared. Notice that this negative comes in here, makes this positive. That's why I have a positive 90x. And then the plus 24 just stays. Okay, are we good on this one? Can I move forward? All right, awesome. The next one is find, I don't know what number we're on. 9. All right, fine. At this point, I'm running. So I'm gonna ask you to find the dy over dx for y equals, and I don't want the full answer. I want you to leave it at the equation, okay? So you have negative 5x to the third minus 5x squared plus 3, and do not simplify is how they express it. This is negative 5x to the fourth plus 2. So do not simplify. I don't want a full answer. That's all they want. So they say do not simplify. So do not simplify means this.
Foil.
Yeah. Keep it just the way you see it. Ahí estamos. Are we in a good place? So far, so good? Okay, I'm moving up to the next one. And yes, in this one it says find D over, I think that's gamma, D over dW, I'm gonna call it dW, equals 4 over, I dare say gamma squared plus 3, all to the 5th power. You know, on this one, I would assume, how many of you are trying to do 4 parentheses w squared plus 3 to the 5th, negative 5th? How many of you are going that route? Good. Good, because think about it. If you do this route, you're going to go 4, 0, right?
Yeah.
And over here, you're going to have w squared plus 3 to the 5th. That's fine. And over here, you have to differentiate, so you get 5 w squared plus 3 to the 4th times 2w. And so you have to do a little bit more work here. So this will become 10w times w squared plus 3 to the 4th. That's your new, I don't know, that looks a little bit more like more work to me. Whereas this, you would get negative 20, right? And then you have w squared plus 3. We're going to take away 1, so this becomes negative 6 times, and over here this becomes 2w. Look how much easier this looks. Okay, so if I multiply these two, I have negative 40w, and this will become over w squared plus 3 to the 6th power, and I believe that is your answer. Much easier than going this route. So this route, no bueno. I mean, you could do it, but ay.
More time.
Yeah, there's a hurricane coming. We gotta hurry up. You cool with that one? Okay. For the next question, we have D. Find d over dx of the 8th root of 8x to the 7th power minus 10. I'm thinking chain rule on this one. Chain rule might be easier for this one. Because if you think about it, I'm just going to set it up. I'm going to let you do it. That's what you have to start. Tell me if you agree with me up to now. Alright, now we multiply over here. That's going to result in 7x to the 6. And we're going to put this over 8x to the 7th minus 10 and raised to the positive 7 over 8. It's 1. So you need a common denominator, right? So 8 over 8 works. So if I do 1 over 8 minus 8 over 8, I get negative 7 over 8, which is what I have here. Bring it down. This is why I have positive. Where are we? You okay with this one? Is anybody really struggling? So far, so good? Good. Okay, next one, more of the same. So I'm gonna ask you to find that first derivative of f of x equal to x squared plus 2 cubed. Chain rule again. Chain rule was the third concept I think I introduced this term. We did product quotient chain. Product quotient chain. And I'm going in order as okay, so chain rule.
Is the general power rule?
Yeah, because you basically are going to use the power of 3, bring it forward, take away 1, and then multiply by the derivative of the inside. So this value gives you 6x. And this you have to FOIL. This is x squared plus 2 squared, which in its own right, you have 6x parentheses x to the 4th plus 4x to the 2nd plus 4, correct? And so if I distribute the 6x, I now have 6x to the 5th plus 24x to the 3rd plus 24x. That should be what we need. This is the first derivative. It's so weird, the time change.
Yeah.
It's so weird. I keep looking out and I'm like, is the vampires coming or something? I don't know. Cover your neck. It's weird. This morning driving to work, it was surreal. It was so bright. Jeez. All right. Are you good with this one? Are you catching on with the chain rule? Because I need you to be able to do chain rule. Okay. We're going to find again the first derivative. Don't get tired of this because I'm giving you lots of practice. You're going to find the first derivative. I'm just putting this here to remind you. Take away 1. And that gives you 8x here. So you have 16x.
Wouldn't it be 8x plus 3?
Look at you. Awesome. So you get 16x plus 6 times 4x squared plus 3x. And now we just FOIL. Okay, if you're not familiar with FOIL, which basically is the first term, inner product, outer product as a sum, if they're both the same, and then the last term is as a product. FOIL, first, outer, inner, last. Do you remember that by chance? Yeah. All right. So 16 times 4, I want to say 64.
Yeah.
All right, so 64x cubed is our first term. In green, I'm going to do, so let me change this to black. Hang on, I'm going to color code this so you can follow me. In green, this term is plus 24x squared. In orange, I have plus 48x squared. And my last term, which is 6 times 3x, I get positive 18x. So obviously the two I'm putting together are these two, right?
Mm-hmm.
All right. Final answer, 64x cubed plus 72x squared plus 18x. And that's my first derivative. Okay, the next question I'm gonna let you simmer on for about a minute. So find the first derivative of natural log of x to the 9th power. Do you remember what you said last time? That might actually apply here.
Professor, did you go to the one before?
Yeah. Got it? All right, so how many of you have this answer for me? You ready to, what do you think it is?
It's 9 ln and over 8x over x. No? 9. No?
What about 9 over x?
Anybody?
9 ln of x, or ln of x to the 8th power?
Yeah,
over x.
9 natural log. The natural log should be its own, natural log x should be its own bracket. This is 8 minus 1, so, or 9 minus 1, which is 8, times x, right? And over x, because remember, natural log of x is just 1 over x. Huh?
I said the rise is going to be different.
Oh, okay. But you got,
With the parentheses.
yeah. Okay. I'm sorry, I have an extra x in here. It's just natural log in here. Take out the x, natural log of 1 over x. All right. Okay, I'm gonna throw a question at you. Let's see how you do. Okay, so this question says find the elasticity of the demand function as a function of P. They're giving you x is equal to the demand of P is equal to 300 over P plus 5. Don't overthink this, by the way. P plus 5 squared.
Professor, we're skipping number 18.
Oh, we're skipping a few questions because they're all over the internet. So the questions I'm going over are the questions you need to focus on. So what do you think about this one? You would have to go back into your chapter regarding elasticity. I think that was chapter 3.7. Take a look at that. There's a formula they gave you that will answer your questions. The formula they gave you. So for this one, you would need to know the formula. And you should get 2p over p plus 5. Using the formula they give you. I could give you this question after this one, but let me give you a minute to see if you find your formulas.
Didn't go over to 20?
Hmm?
Oh, negative b by the derivative, I don't know how to say it, of p over f of p.
So the derivative of p,
No.
I'm not following you.
Multiplied by the derivative.
You're saying derivative?
Yeah.
Derivative?
B over. No, all of that over.
I don't want to play anymore. Alright, one more time.
Nah, I have the formula, but I just don't know how to say it.
Bring it up. Let me see what you have. What page did you find it for everybody to know?
I don't have a page, it's just my notes.
What page? It has to have a page written somewhere.
No, like,
Oh, you're
for
saying-
example,
Never mind. My bad. Let me see. I thought you were referring to a page. No, I'm not playing that game anymore. I don't like it. Okay. Alright. So E of P is negative P times the first derivative of P over F of P. Yeah, so. Good job. Which basically is what I just gave you. I am going to write down one question, but like I said, it's all over the internet. I don't want to include questions that I know that you guys, if we do the test online, you can just look up. Okay, so I don't think that's cool. But I'm gonna show you the question, let's talk about it. In case we do it in class. And that equation was, if $2,000 is invested at an annual interest rate R compounded monthly the amount in the account after 5 years, hieroglyphics is what that looks like, is given by, and then they give you the compounding formula equation. They want us to find the rate of change. So if you set it up, we know that we have, based on the formula, that future value, which is going to equal that $2,000 investment times 1 plus R over 12, right? Because it's rate over compounding period raised to the compounding period times 5 years, which is 60 basically, right? So if you don't mind, I'm going to just write 60. So this is just 60. Just remind yourself that that is basically 12 times 5. All right, and so what's the first thing that comes to your mind? We're solving for this little guy. They specifically want to find the rate of change. The rate of change. You're not thinking wrong. The rate of change of the amount A with respect to the interest rate. And the interest rate is R.
If you don't finish, reviewing everything.
I'm gonna review every concept. I already timed it out. I'm good. We're good. So I'll tell you what, I'm gonna leave you here with this answer. And you guys think this through. I'll leave this as a bonus question for you. How about that? I am gonna change the numbers, they're not gonna be the same. But you can figure out why T is what a T is. Now, please remember this. It's rate times time, or NT, compounding period times time. So if I'm looking for a rate of change of 1 year, think about that. Because remember, I'm going from an exponent of 60 to an exponent of 59, so I've gone down 1 of something. One. Possibly, but I'll leave you with this. That'll be your think. That'll be your think. This will be a bonus question, if anything. And I'm gonna make it a wonderful bonus of 20 points. If you can show your work and get it correct. And I hate to say this out loud, but it's all over the internet. So if you want the solution, or at least the guideline, there you go. Okay, let's continue forward. The next question that I have for you has to do again with elasticity. Another elasticity question. And they're giving us an FFP equal to $570 minus 8P. And they want to know at what point does it have unit elasticity? Another formula you need to remember. Unit elasticity. So what do you think the value would be for this one? Unit elasticity. Look at your notes. There's a specific formula. I'll give you a hint. P should end up resulting in 35.63 rounded. There's a formula.
You have to do it equals to 1.
Okay, so you're saying 570. What are you saying to me? You wanna set this equation 570 minus 8p equal to 1, that's all you wanna do? There's more to it. There is more to it.
Would it be 570 minus 8? Oh wait, no, it would be negative 8 divided by 570 minus 8p times 1, all times.
What did it come to? We know that if we were to simply do 570 equal to positive 8p, and we divide by 8, we know we get double that amount. We get 71.25. It's actually not. Excuse me. You have to divide again by 2. What formula are we using to get that? Okay, it's in your notes. I'm not gonna waste review time on that. It's a formula. You're looking for unit elasticity. There's a formula that I gave you in your notes. Okay. I'm gonna do the next 3 a little quickly, just because. So in the question, they're giving us a graph. And I don't really have an equation to go with, but I can at least do a nice clean graph as best I can. So this is like negative 100, negative 200, negative 300. That's enough. I'm going to go by 2's here. So I'm going to go with 2. This is 4. This is 6. This is 8. Let's go 10, 12, just for the sake of. Okay, on the other side, I'm going negative 2, negative 4, negative 6, negative 8, negative 10. And up here, it's going up by 100. So 100, 200, 300, 400, and so on. Okay, I can tell you that it is crossing this section here and going straight up. It is doing like a little U-turn about here and then going straight to the origin. So that's that side of the graph. Over here, it's coming up. It's going to go again. It's going to do this right about here. And it's going down. So then what they're asking is, in this graph, at which point is that value greater than 0? What interval? And at what point is that value of this equation less than 0? So what intervals is it increasing? What intervals is it decreasing? So think about this in terms of increasing and decreasing. What would you say? Where is it decreasing? Remember, you read this left to right. So
that's the graph of f prime.
that is the graph, yeah.
So it will be from negative infinity all the way to negative 7,
Mhm.
increasing from 0 all the way to 7.
But on the x values, look at it on the x values. So like from negative 4 to 4, would you agree, looking at the x's? Negative 4 to 4, what's it doing? Increases, yeah. So you would answer in this case, the greater than 0 would simply be negative from negative 4 on the domain to 4. These are domain values. I'm not saying you're wrong, because you're not wrong. But I'm just giving you a heads up on the test. That's what they're asking. Domain. Now, where is it decreasing? Which is what I think you were starting to say. Negative infinity is over here, so I'm looking at this as a decrease. All right. So, yeah, so this is dropping from negative infinity to negative 4 on the domain. Union what?
There's a four to positive.
There you go. I think that's what you were saying initially.
No, I'm confused with something else. When, there is a graph that whenever the values, like, are on the positive, like the x values are positive, I'm just confused with something. With it.
But do you understand where
Yeah.
we're getting this
Yeah, yeah.
nonsense there? Let me do this in red, just for the sake of the decreasing in red, decreasing in red. That's these guys right here. All right. You have maybe one or two questions of that type. Here's another one. This is, I was gonna use Desmos because I think it's better than a drawing. So let's pull Desmos up for a minute. Today. Oh my god, of all the times I want this computer not to show that face. Okay. Desmos, thank you. There you go. Alright, so we're at x raised to the third plus, they love this function. I swear I think I see this function in every book. 3x squared minus 24x. And they are asking here, okay, so yes, you have to shrink it. Okay, so yes, you can use Desmos if you have to. What do you notice there? Little dot. What number is that? So what's happening from -4 to, or negative infinity up to -4? What's happening? It's increasing. All right, and what would you say at this cutoff? So let me go back to the minimum. What number is that? To -22, right?
Right.
So what's happening from 2 to positive infinity?
Increasing.
And what's happening there from -4 to 2?
Decreasing.
Decreasing. So, and from 2 to positive infinity? It's increasing. Okay. So you might have a graph similar to that. All right. So that's another one of your questions. I may ask you to simply sketch a graph. So if I said to you, sketch a graph, I don't know, this question kind of sucks, but I would need you to, if I was gonna use that question, I would have you not use Desmos. Not gonna do that to you. I'm not gonna do that to you. Because I think it'll help you to use Desmos in one question in particular. All right. Let's look at the following. The annual revenue. Oh, do you know your profit function equation?
P equals R minus C.
Yeah, just remember P of X is equal to R of X minus C of X. Don't forget that because you're going to need that. So the annual revenue and cost functions for a manufacturer of grandfather clocks they are the following. So they give you R of X is equal to 500 X minus 0.01 X squared and C of x is equal to 200 x plus 100,000. They want to know what is the maximum profit. So if you recall this, one of the equations I told you to find just now is what is the P of x. Once you find the P of x, I then need you to use the negative b over 2a formula, which gives you x, and then I need you to plug it back in and find the answer. If you can do that, you should be great. So this P of x formula is going to simplify because I get 500 x minus 0.01 x squared minus 200x, because remember you're going to subtract both of these, minus 100,000, which simplifies. You get P of x is equal to 300 x minus 0.01 x squared minus 100,000. And again, you can rearrange this, and if you do negative b over 2a, which is the axis of symmetry, that's going to give you negative 300 over 2 times negative 0.01, which gives you 15,000. You're then going to throw it back into the equation. Throw it back into the equation, you find that P of x is going to equal $2,150,000. Okay? So it's a fairly simple question. Almost done. And I'm covering everything. Nothing is going to be left uncovered, I promise you. Nothing that's on the test. I promise. Okay? Okay, so here's the thing. I'm going to give you a graph. And that graph is going to have some sort of equation doing some dance like this. And I'm going to ask you to find the intervals where the concavity, remember second derivatives and we talked about concavity?
Yeah.
So are you throwing money at a losing cause, basically, right? So I'm going to tell you it's either concave upward or concave downward, okay? And you're going to tell me the interval. So for example, just to play devil's advocate here, let's say this is -1 and let's say this is -8. Which interval is this concave downward? Hello? -8 to -1? All right. And what interval would this or what interval could this be concave up? So let's say this is I don't know, let's say this is +8. And let's say this is still -1. More specifically, why do we care about concavity? Can you find the second derivative? That was the other question that I asked you to understand. If I said to you, I have a question that says find the second derivative, and let me be obnoxious. I'm going to give you this one. Let's say I have -7x to the 9th plus 5x squared. What would you do for that?
You have to find the first derivative.
Okay.
And then times.
Okay, so what is the second derivative?
The second derivative is -504 x to the 7 plus n.
Yeah. That's it. And what happens, remember, to be able to interpret it, if the indicated value for the second derivative yields you a negative outcome versus the second derivative giving you a positive outcome. Remember, it referred you to a page. Be able to interpret what it means. So interpret what that means. I also want to know what your critical points tell you.
Critical numbers.
Your critical numbers and yes, the critical numbers and how you interpret the first. There's a whole chart I did with you, and I talked to you and I said, well, what happens when this is positive and what happens when this is negative and so on. I remember referring you to that page.
The prime is decreasing and increasing, and therefore price concavity.
Right, and then concavity tells you what? Yeah, so study that. Huh? What?
No, I say if it's going up or down.
Correct. In the points, can you find an absolute minimum versus a maximum? So basically, if you have a graph doing this thing, right? Can you find the minimum? Can you find the maximum?
Yeah, the minimum would be the bottom up there. And that, yeah.
So nothing I haven't gone over that you haven't understood, I think, and also consider the fact that even when we do word problems, like, so let's finish with this one. Is today Monday? So yeah, and then that means that that class is coming in. So let me be quick. The annual revenue and cost functions for a manufacturer are R of X equals 520, doggone it, 520x minus 0.02x squared, and the cost function, the C of x, is equal to 160 x plus 100,000. They want to know what's the maximum annual profit. What is the maximum annual profit? Again, you have to go back to your formula, P of x, okay? P of x, which is var of x minus C of x. See if you can follow the instructions on the previous question and see if you can answer this. Go ahead, and I'll give you, actually, I'm going to give you the answer just in case we got thrown out. You should end up with 1,520,000 as your max profit.
What's the last word of the sentence there?
Manufacturer? Manufacturer? Here?
Yeah. Oh, that's manufacturer.
Manufacturer. Anytime they ask max or min, negative b over 2a. And that goes back to basic foundations, right? So you go back to your ax squared plus bx plus c formula and use those values. Negative b over 2a. That gives you the x value. Once you have x, plug it back in. All right?